In this video lecture, we're going to talk about stimulus control. And the first thing to be that we need to be aware of, that we need to keep in mind, is that behavior never happens in a vacuum. So it always happens in a particular context, which means that there is some stimuli that precedes the presentation of the behavior. So if you think of, for instance, the rat in a instrumental operant conditioning situation, uh, the rat, before it does anything, before it lever presses or it does anything, there is a that happens inside a box, um, and it's inside that box that with the lever that the rat engages. This is a rat engages in lever pressing behavior. Think about any behavior, and it's always possible to identify a context in which it happens, and that context is always a stimulus, is part of the environment. In the case of instrumental or operant conditioning, that environment, those stimuli, are the antecedents. Oh, sorry, are the antecedents that or the antecedent that we've referred to when we've done our A, B, C consequence. So remember, this is our three-term contingency, and one so far in previous chapters we've talked about a lot about how the behavior is controlled by its consequences. When we've talked about reinforcement, when we've talked about um, when we talk about punishment, various different schedules and different contingencies. The contingencies have always specified up to now um, how the behavior results in certain consequences. Now we're going to be focusing on how the antecedent actually relates to the behavior. And as we've mentioned before, one way of thinking about this antecedent and this consequence in operant conditioning is in terms of a US and a CS in Pavlovian conditioning. That's because this kind of Pavlovian relationship between these two stimuli, the antecedent and the consequence, is present within, it's embedded within operant conditioning. Okay, so you can also think about this kind of antecedent behavior in Pavlovian conditioning in terms of the presence of this CS. So when we're talking about um, fear conditioning, for instance, in which the CS may be, in that situation, may be a tone, and the US is foot shock, and the condition response, the behavior is freezing to the tone, then freezing is happening only in the context of the tone and not when in a well-trained animal. It's not happening when the tone is absent. Right? Now, fear conditioning is not operant conditioning only because the freezing behavior has no um, meaningful consequence, no programmed consequence at least. Shock appears whether or not the animal freezes or not. That makes it Pavlovian conditioning. In this case, in the case of operant conditioning though, the consequence, the US is appears as consequence of behavior. All right. So in the so one way in which we can have pretty good control over the antecedent in operant conditioning is by presenting a particular stimulus. So there may be this may be a light that signals that a particular contingency is in effect, right? So this light may indicate that lever pressing now results um, in food pellets. But if the light is turned off, then no food pellets are available with lever pressing. And so we will refer in that situation to the light as the discriminative stimulus, or SD oftentimes. And no light, or a light of a different color, or whatever it may be, that signals that the contingency is not in effect, that is, that behavior does not result in a particular consequence, as an S delta. Right? We don't have a particular word for S deltas, we usually call them S deltas. The light's often called an SD, or a discriminative stimulus. We'll see why the discriminative adjective is important, why this refers to discrimination. So this is the case of operant conditioning. Again, uh, in um, in the case of Pavlovian conditioning, you can think about a similar situation in which you have a CS, and we call it often this time a CS plus, the one that indicates that that is associated with food shock, and a CS minus that indicates that um, maybe another stimulus, let's say a different tone. Let's say this may be 3 kilohertz tone, that's a relatively low tone, and this may be a 10 kilohertz tone, a relatively high pitched tone. That means no food shock. Right? As to make it a little bit more symmetric, let me change this example from light and no light to let's say a white light and a green light. Right? So when we say that we have, strong or good stimulus control, it means that the stimulus that we're referring to is controlling the behavior. Its presence results in the behavior. Its absence results in the absence of the behavior. So if when we turn on the white light in this operant condition example, when we turn on this distributive stimulus, we observe lever pressing, and when we turn on the green light, we do not observe lever pressing. Notice that this is sort of like a switch, right? You're turning on and off behavior by turning on and off this light, and the light is controlling the behavior. So we refer to that as having strong or good stimulus control. Same thing, and this is the case in operant conditioning. In Pavlovian conditioning, of course, as Pavlovian conditioning, you have a very similar situation in which you turn on the 3 kilohertz tone, a low frequency tone, and that results in the animal freezing because it's anticipating food shock. Whereas when we turn on the 10 kilohertz tone, there is no food shock, and what we should see is that the animal does not freeze. And so behavior is turned on and off by presenting the CS, one CS or the other. So that's what we refer to as stimulus control. And notice one thing that it's particularly interesting. Well, there are two particularly interesting aspects of this kind of switch. Let me draw it right over here. The first one we call stimulus generalization. And it's the fact that even though your switch may be very effective, the stimulus that you're using to control the behavior may be very effective, similar stimuli may have similar effects on the behavior of the animal. So think of what would happen in an animal that is well trained with this white light, green light discrimination task, which white light serves as SD, green light as S delta. White light should result in lever pressing, green light in no lever pressing. Suppose you present a very light yellowish light that the animal has never seen before. What do you think would happen? Most likely the animal will respond to that light a little bit, maybe not as strongly as to the white light, but it will probably respond to some extent. Let me erase this part so I can make some space. So a typical example is used actually from a classic experiment is, suppose that we're talking about a pigeon that is trained to peck on a circular key. Key is like an elevator button that has a vertical light in the middle. And now so this is our stimulus on the x-axis, or actually it's the, most precisely, it's the angle of this line in the middle, and the animal has been trained on this 90-degree angle line, right? And this is rate of responding. And because the animal has been trained on this particular stimulus, pecking when this stimulus was on, resulted in a high rate of responding. Then when you present, it's very important, this is the training stimulus. And then you test what happens when you present a slightly different angles. Sorry, not ideal drawings, but you get the idea that we're changing the angle of the line from 0 degrees all the way to 180, which look very similar. And in the middle it's 90 degrees, which is the training stimulus. And because a training stimulus, in the presence of a training stimulus, key pecking was reinforced, rate of responding should be maximal at this point. And then we should see that responding may not be as strong. Maybe drop down all the way down. It will be weaker, weaker, weaker. The more different the stimulus, the testing stimulus is from the training stimulus. And we call this a generalization gradient. Generalization gradient. Right? And what it shows is that even though you trained, this was your SD. This was your SD. Even though you trained explicitly the animal on this SD, similar stimuli are also effective to a lesser degree, but still effective to elicit some responding to the extent that they are similar to the training SD. And so there's a generalization of the stimulus um, in terms of their effectiveness in controlling behavior, right? And you can see a similar thing in Pavlovian conditioning. If we present a 4, 5, 6 kilohertz tone, then we'll probably get some freezing, maybe not as strongly as with a 3 kilohertz CS plus, but we'll get some because of a stimulus generalization. Right. The flip side, of course, of stimulus generalization is a stimulus discrimination. Let's put it here. Stimulus discrimination. And what it means is that this is where the term discriminative stimulus comes from. And notice that one particular thing that's interesting about this preparation, and that is that for the white light in this example to be an effective SD, one of the things that need to happen is that the animal has to be able to discriminate between white light and other colors, like say the green light in this experiment, in this example. Or for this to happen with a different angle line, this demonstrates the fact that you get more responding on this line than on other lines. Indicates that the animal can discriminate between lines of different angles. If that wasn't the case, if the animal could not distinguish between lines of different angles, we should see rate of responding not changing across different stimuli. They all look the same to the animal. There's no reason for the animal to respond differentially to either one of them. Same thing here. If the animal could not distinguish between white and green, if it was blind to that distinction, then the animal should respond exactly the same to the white SD as to the green S delta. The fact that the animal discriminates between the two is what allows the animal to respond differently to the white light and to the green light. That's what we mean by discrimination between stimuli, that the animal responds differently or differentially to each of these stimuli. And the same thing in the Pavlovian conditioned example. If the animal could not distinguish, let's say the animal was deaf, it could not distinguish between a 3 kilohertz or a 10 kilohertz tone, then it will freeze or behave exactly the same to a CS plus and a CS minus. It will not demonstrate any stimulus discrimination. Right? Okay, so the last part of this of this topic has to do with the peak shift effect, and that is going to be in the next video lecture.